Hello, this is Mrs. Dowell, and today I'm going to talk with you about how to rationalize the denominator. So I'm going to set up this point here located at approximately 2, 4, and this is my vertical and my horizontal distance here laid out. And I am interested in finding how far that point is from the origin. This is going to be a good example of how to teach how to rationalize. Now, this point 2, 4 is on the terminal side of an angle that goes from basically the x-axis all the way up to this angle. And so what I am going to show you how to do is how to, number one, find the distance from the origin to that point, and then number two, how to rationalize your answer. So I've simply labeled the points here, 2 and 4, and C is the distance I'm interested in, and I'm going to use Pythagorean Theorem. And we're very familiar with how to use this. My A value is 2, my B value is 4, and C is what I'm looking for. So I do the math here, and I end up with my C squared being 20, which means that C is equal to the square root of 20. Now in this particular module, they're interested in a few things: how to find the sine, how to find the cosine, and how to find the tangent. And I always use this little trick to remember how the ratios go. So for sine, it is opposite over hypotenuse. And then for cosine, it is adjacent over hypotenuse. And then for tangent, it is opposite over adjacent. So I always use the trick, oh heck, another hour of algebra, to remind me. Now I know that my distance C is the square root of 20. So when I'm looking at the ratio for sine, I know it's going to be 4 over the square root of 20. And then I know that my cosine is going to be 2 over the square root of 20. And my tangent is going to be 4 over 2. And that's great. We love that because that's equal to 2. So now my goal is to simplify and rationalize the 4 over square root of 20 and the 2 over square root of 20. And this is called rationalize the denominator. The reason we rationalize the denominator is because it is not proper for us to leave a radical sign in the denominator. Mathematically, it is correct, but it is not proper. So I'm going to start out with my original fraction, and I'm going to multiply by 1 in the form of the square root of 20 over the square root of 20. Then when I multiply across, I get 4 times the square root of 20 over just simply 20. The square root of 20 times the square root of 20 is equal to 20. Now I'm going to simplify. 4 over 20 reduces to 1 over 5. So I have the square root of 20 over 5. Now I have rationalized, but I need to simplify. So I can rewrite the square root of 20 as the square root of 4 times the square root of 5 all over 5. And I know that the square root of 4 is 2. So this answer becomes 2 rad 5 over 5. Okay, so I have not only rationalized, but I have simplified. Okay, now I'm going to go to another page, and I'm going to talk with you about 2 over the square root of 20. Need plenty of room. We just did 4 over the square root of 20. Now let's work on 2 over the square root of 20. You can see that reducing is a critical part of simplifying your answer. So how to rationalize this fraction is simply multiply by the square root of 20 over the square root of 20. That is just simply 1. So this becomes 2 times the square root of 20 over 20. Again, the remainder, square root 20 times square root 20, is equal to 20. So my denominator is 20. Now 2 over 20 reduces very easily to 1 over 10. So the square root of 20 over 10. But I'm not done. Once again, the square root of 20 can be written as the square root of 4 times the square root of 5 all over 10. And the square root of 4, again, is 2. So if I write a simplified answer, 2 times the radical 5 over 10, yet it is still not simplified. Canceling out where you can, my final answer is the square root of 5 over 5. So in this process, I have rationalized, simplified my radicals, and simplified my fraction so that you see 2 over the square root of 20 actually equals the square root of 5 over 2. I hope that this has been helpful for you.